1050. Buckle your seatbelts, everyone, because I'm telling you straight up, there's going to be a lot of work for this one. All right, use what you have learned in the previous problems to help Myron calculate the volume of the pool in problem 1047. So, as we mentioned in problem 1047, Myron needs to know the formula for a sphere and a cylinder, right? Because our pool, either end of it is a quarter of a sphere, which means when we push them together, it's half of a sphere. And then we also have half of a cylinder. So this seems like an awful intimidating problem, but I guarantee you we've got the knowledge to do it. It's just a lot of steps. So let's get down to business. They give us some measurements here. So they tell us all the way across the pool. So the length of the pool is 40 feet. And it looks like the entire depth is 10 feet. So let's go ahead and start with the volume of a cylinder using what we know. So now remember, our shape is half of a cylinder. So we want to take half of whatever it is when we find the volume of a full cylinder. So let's go ahead and start with the volume of a cylinder now. So if you recall, and again for this one, make sure you write what I write. So the volume of a cylinder is pi r, which is radius, squared times the height. All right, so in this case, the radius of the cylinder, now the cylinder and the sphere are going to share the same radius, right? So the radius is going to be like this part of the circle because it's halfway, or I guess the sphere, because it's halfway from the very center to the outer edge. Now, we know if the pool is 20 feet here, and it's 40 feet altogether, then this has to be 10 feet and this has to be 10 feet, right? Because that's what would add up to 40. So our radius is 10. All right, we need to square that. And then the height of the cylinder is going to be 20, right? Because that's what this is. That's the height of our cylinder. Even though it looks like, from this view, it does look like, a rectangle, keep in mind that's only the 2D view. And that's like us viewing the pool from the top, like a bird's eye view. All right, so now that we have that, let's go ahead and plug it into our calculator. And again, if you, I guess regardless what calculator you're using, you want to use the pi button instead of 3.14 just because it is more precise. And that is something that we are always striving for in math. So we're going to do pi, but we just put it in exactly as it's written there. So pi parenthesis 10 and parenthesis squared parenthesis 20 and parenthesis. So in terms of pi, if you're using a TI-34, it's going to give you 2,000 pi, okay? But does that really make that much sense? Well, how much water do we need to fill our pool? Well, 2,000 pi. What? Right? So we like to use the decimal approximation, and if you're using a TI-34, all you have to do is hit that double arrow button and it will change it to the decimal approximation. So if we're rounding to the nearest hundredth, that's going to be 6,283 and 1900ths. Now, keep in mind, this is for a full cylinder. All right, so we are looking for half of a cylinder, right? Because our pool is, it's not a full cylinder, it's only half. So we want to then find the volume of just that cylinder, or I'm sorry, just that half of a cylinder. So we're going to do 1/2 times 6,283.19. Now you could divide by 2 if you prefer. It's the same thing. So multiplying by 1/2, dividing by 2, it's going to give you the same thing. So let's take that number, and so it's that 6,283.19, and we're multiplying by 1/2. That's going to give us approximately, and again, if we're rounding to the nearest hundredth, about 3,141 and 60 hundredths. All right, so this answer here, this is for that half cylinder part. Now we need to figure out the volume of either end. And we talked about if we take out that middle cylinder part and we push the two ends together, that creates half of a sphere, right? So now what we need to do is we need to get the volume formula for a sphere. And to find the volume of a sphere, it is going to be, V equals, it's going to be 4/3 pi times the radius cubed. All right, so let's go ahead and start plugging in. So again, that's 4/3 pi and times the radius. Now we talked about earlier how the sphere and the cylinder share a radius. Now the radius of the cylinder was 10, so that means it's the same for my segments of the sphere as well. All right, so we have done that. We've plugged in everything we can plug in. Now the rest is just calculator work from here. So let's go ahead and put in our calculator. We're going to do exactly what's written. So 4/3 pi button, parenthesis 10, end parenthesis, and cubed. So it's going to give us my TI-34. It gave me a decimal approximation. It did not give me the answer in terms of pi, which is fine because we do want a decimal approximation. And if we round to the nearest hundredth, it's going to be 4,188 and 80 hundredths. All right. Ooh, I shouldn't have boxed that in. So keep in mind, this is for a full sphere. We are looking for half a sphere. So we're going to do the same thing as we did with the cylinder. And we are going to multiply by 1/2. Now, if you want to divide by 2, we talked about that's the same thing. Divide by 2 if you prefer that. You get the same answer either way. All right, so we're going to do that number and multiply by 1/2. And when we do that, we are going to get, if we round to the nearest hundredth, 2,094 and 40 hundredths. All right, so now we have the volume of half a cylinder and half a sphere. So what we need to do is we need to add those together, and that gives us the total volume for the pool. So 3,141 and 60 hundredths plus 2,094 and 40 hundredths. Now let's see, did it give us labels here? Feet. All right, so we're dealing with feet. All right, So 3,141 60 hundredths plus 2,094 and 40 hundredths is going to give us, actually exactly on my calculator at least, 5,236. Now it's going to be labeled cubic feet, right? Because it's volume. So that is how much water will go in the pool. So nice job getting through this. I know it was a lot of steps, but we've reached it, and this is the end.